Assalamu alaikum students. After we have read the mobility, now today our topic is going to remain relation between drift velocity and electric current. We are aware of the drift velocity. Drift velocity is the velocity with which these negatively charged electrons are going to get drifted, going to move in a particular direction once there is application of potential difference. So in order to derive the relation, we have chosen a conductor whose length is L and whose area of cross section is A. If A is its area of cross section and L is its length and V be the potential difference, and these electrons are going to get drifted opposite to the direction of electric field with a velocity of Vd. So on a length L we have applied a potential difference of V. So on unit length it will be simply E equals to V over L. On length L, by unitary method, on length L we are having a potential difference of V. On unit length we are having a potential difference V over L, and that's called as what? E. So simply I put it here that the magnitude of electric field which is set across the city conductor is E equals to V by L. And now if I will take n is number of free electrons per unit volume. If n is the number of electrons per unit volume, so if we are having a volume as it's having an area A, length L, so its volume will be A into L. In unit volume we are having n as a number of electrons. So total electrons, if n is the number of free electrons per unit volume, then total number of electrons in the conductor is n into volume of conductor, and that volume is A into L. So simply NaL with the number of electrons in the conductor. And if now charge on each electron is E, if now charge on each electron is E, then then total charge in conductor is Q equals to NaL into E. So this is the total charge which is present in what? Which is present in the semiconductor. Now the time taken by charge to cross the length, as electron has to move from here to here. So what's the time? The time taken by charge, now time taken by charge to go from this end to this end to cross a length L is given by time taken by charge, or what I mean to say electron, the charge here electron, charge to cross the length, is t equals to, time is given by distance by speed, the total distance which the electron has traveled, that's L, and speed that's going to move with the drift velocity, that's Vd. So this is the time. So in order to calculate the relation between drift velocity and electric current, I will now say, now by definition of electric current, I equals to what? Q over T. But we have now written Q equals to what? N A L into E divided by T. T equals to what? L over Vd. Or you will say like this L and L is going to leave, it is N A E Vd, this I. So that is I is directly proportional to what? I is directly proportional to Vd, the drift velocity. N is constant, E is constant, A is constant as you are going to use the material, then I is, that is I directly proportional to Vd. More drift velocity means more current. But since we're having another relation, since Vd equals to what? Mu into E. Therefore I equals to N E A mu into E. Also Vd, the drift velocity, is equal to E tau by m. Tau by m. So we're going to use its value, as we're having mu into E. We're going to use there Vd, and instead of Vd we're going to put it like this. So therefore I equals to N E A. Now mu into E, that is Vd, and instead of Vd we'll plus E tau by m, which simply comes out to be what? Therefore I equals to N E square A tau over m. This is the relationship between what? This is the relationship between this drift velocity and electric current, as we have shown out already. The drift velocity is directly proportional to the drift velocity is directly proportional to current, and this is another relation which we are going to use, because instead of this very term E tau by m, E tau by m, we are having Vd. You can use directly Vd here as in the equation. So this is a relation, this relation, or this relation, which you have to remember. These are the relations you have to remember. So this was the topic which we have to read. This equation, these three equations you have to remember. This is the relation between drift velocity and electric current. Tomorrow will be another lecture. Till then, Allah Hafiz.